Imagine a world where the oceans, once teeming with life, begin to turn against their inhabitants. The vibrant coral reefs, bustling with colorful fish and marine creatures, start to fade and deteriorate. The once clear waters become murky, and the harmonious underwater symphony is replaced by an eerie silence. This is not a scene from a science fiction movie, but a very real and present danger ocean acidification. The oceans, which cover more than 70% of our planet, are undergoing a dramatic transformation that threatens the delicate balance of marine ecosystems. As carbon dioxide levels rise in the atmosphere, a significant portion gets absorbed by the oceans. This process, while initially seeming beneficial as it helps to mitigate the effects of climate change, has a darker side. This absorption, while seemingly beneficial in slowing climate change, sets off a chain reaction that alters the very chemistry of seawater, making it more acidic. The increased acidity disrupts the natural balance, affecting everything from the smallest plankton to the largest marine mammals. This acidification, though gradual, has potentially catastrophic consequences for marine life, ecosystems, and ultimately humanity itself. Fish and other marine species struggle to survive in these increasingly hostile conditions, leading to a decline in biodiversity. Picture a once thriving coral reef now bleached and barren, its intricate structures crumbling under the pressure of increasingly acidic waters. Coral reefs, which are vital to marine life, providing shelter and food for countless species, are particularly vulnerable to these changes. This is just one example of the devastating impact of ocean acidification. The ripple effects extend far beyond the ocean, affecting human communities that rely on the sea for food, livelihoods, and cultural practices. If we do not take urgent action to reduce carbon emissions and protect our oceans, the consequences will be dire for all life on Earth. The most direct and visible impact of ocean acidification is on marine organisms that rely on calcium carbonate to build their shells and skeletons. Creatures like oysters, clams, mussels, and corals are particularly vulnerable. As the pH of seawater drops, the availability of carbonate ions, essential building blocks for these organisms, decreases. Imagine trying to build a house with bricks that dissolve as you lay them. This is the challenge these creatures face in increasingly acidic waters. Their shells become thinner, weaker, and more susceptible to damage, making them easy targets for predators and threatening their very survival. The impact of ocean acidification extends far beyond shell-forming creatures. The intricate web of life in the ocean means that even subtle changes in water chemistry can have ripple effects throughout the ecosystem. Fish, for instance, rely on their sense of smell to find food, detect predators, and even locate their home reefs. Studies have shown that ocean acidification can impair the olfactory senses of some fish species, making it harder for them to navigate their environment and survive. This disruption of basic sensory perception can have cascading effects up the food chain, impacting entire populations and ecosystems. Ocean ecosystems are delicately balanced with intricate relationships between predators and prey. Ocean acidification has the potential to disrupt this balance, leading to unpredictable and potentially disastrous consequences. For example, some studies suggest that ocean acidification may benefit certain types of algae, leading to algal blooms. While this might seem like a positive at first, excessive algal growth can deplete oxygen levels in the water, creating dead zones where marine life cannot survive. Such imbalances can have cascading effects throughout the food web, impacting the abundance and diversity of marine species. Section 5. Coral reefs. Cities under siege. Coral reefs, often called the rainforests of the sea, are among the most diverse and productive ecosystems on Earth. They provide habitat for a staggering array of marine species and offer numerous benefits to humans, including coastal protection, tourism revenue, and even potential sources of new medicines. Ocean acidification poses a grave threat to these underwater cities. As the water becomes more acidic, it becomes increasingly difficult for corals to build and maintain their calcium carbonate skeletons. This weakens the reef structure, making it more susceptible to damage from storms and erosion. Section 6. Empty nets, the human cost. The consequences of ocean acidification extend far beyond the marine environment, reaching our dinner plates and impacting global food security. Millions of people around the world depend on seafood as a primary source of protein and income. As ocean acidification threatens the health and abundance of fish stocks, it directly impacts the livelihoods of fishermen and the economies of coastal communities. The potential for food shortages and economic hardship is a stark reminder of the interconnectedness of human society and the health of our oceans. Section 7. Beyond the surface, a cascade of consequences. The impacts of ocean acidification are not limited to the marine environment. This phenomenon, driven by the absorption of excess atmospheric CO2 by the world's oceans, leads to a decrease in pH levels, making the water more acidic. This change in the ocean's chemistry can have devastating effects on marine life, particularly organisms that rely on calcium carbonate to form their shells and skeletons, such as corals, mollusks, and some plankton species. Changes in the ocean's chemistry can have far-reaching consequences for the entire planet. The delicate balance of marine ecosystems is disrupted, leading to a cascade of effects that can impact biodiversity, fisheries, and even human communities that depend on the ocean for their livelihoods. For example, as the ocean absorbs more CO2, it reduces its capacity to absorb heat from the atmosphere, potentially exacerbating climate change. This is because the ocean plays a crucial role in regulating the Earth's climate by absorbing and storing heat. When this capacity is diminished, it can lead to an increase in global temperatures, which in turn can cause more frequent and severe weather events. Furthermore, acidification can alter the ocean's ability to regulate global temperatures, leading to more extreme weather events and further disrupting ecosystems on land and at sea. Coastal communities are particularly vulnerable to these changes, as they face the dual threats of rising sea levels and increased storm intensity, which can lead to devastating flooding and erosion. The intricate web of life on Earth means that even seemingly distant changes in the ocean can have profound and unpredictable consequences for all living things. From the smallest plankton to the largest whales, and from coastal mangroves to inland forests, the health of our oceans is inextricably linked to the health of our planet. Protecting the ocean is not just about preserving marine life, it's about safeguarding the future of all life on Earth. Section 8, a call to action, our shared responsibility. The threat of ocean acidification is a stark reminder of the interconnectedness of our planet and the consequences of human actions. The choices we make today will determine the fate of our oceans and the countless species that depend on them, including our own. Addressing this global challenge requires a collective effort. We must reduce our reliance on fossil fuels, transition to cleaner energy sources, and invest in sustainable practices that minimize our impact on the environment. Section 9. Turning the tide, hope for the future. While the challenges posed by ocean acidification are significant, there is still hope. The ocean, vast and resilient, has always been a source of life and inspiration. Despite the mounting pressures, it continues to offer us a chance to make things right. Scientists are working tirelessly to better understand the complex processes involved and to develop solutions that can mitigate the impacts. Their dedication is unwavering as they delve into the intricacies of marine chemistry and biology, seeking answers that could pave the way for a more sustainable future. From exploring ways to enhance the ocean's natural carbon storage capacity, such as through the restoration of seagrass meadows and mangrove forests, to investigating the potential of artificial reefs and other innovative technologies, to developing innovative approaches to aquaculture that can withstand changing ocean conditions, ensuring that our seafood supply remains stable and sustainable. The pursuit of solutions is a testament to human ingenuity and our commitment to preserving the health of our planet. Collaborative efforts among scientists, policymakers, and communities are crucial in this endeavor. Ocean acidification is a global crisis, but it is not insurmountable. By leveraging our collective knowledge and resources, we can address this challenge head-on. By acknowledging the urgency of the situation, raising awareness through education and advocacy, and fostering a sense of global responsibility, investing in research and innovation, and embracing sustainable practices, we can create a ripple effect that leads to meaningful change. The development of cutting-edge technologies and the implementation of effective policies are essential steps in this journey. We can turn the tide and ensure a healthy future for our oceans and for generations to come. It is a collective effort, one that requires the participation of every individual, community and nation. Together we can safeguard the beauty and bounty of our oceans for the future.